Hey, what's up guys, my name is the Cherno. Welcome back to my Game Engine series. So last time we introduced Sprite Sheets and we more or less talked about how they work. They're also called texture atlases. Check out that video if you haven't already. The most important thing that I want to do today is actually work out some kind of API for our texture atlases. Now this is something that I haven't really sat down and planned because I figured it would be probably a good process to show you guys what I was thinking and kind of just do it live instead of just being like, here we go, let's do this. But basically we're just going to jump in and we're going to try and figure out a way for ourselves to, I guess, define and use sprite sheets. Now, straight off the bat, I want to say that this is something that at the moment, the small amount of thought that I have given it, which has been mostly during this introduction that I'm now giving you guys, I haven't really... There are a lot of ways that you could implement this, and unfortunately it's one of those things that tends to be according to your preference, because when you think about a sprite sheet, what is a sprite sheet? So at the core, we have a texture and then some kind of index into that sprite sheet, which we can use to determine the needed or the required texture coordinates to render something, more specifically a textured quad. So basically, if we break all of this down, and that's probably the best thing to do in pretty much any situation, just to break everything down to the actual data required. So what is the actual data that we need? Well, we need a texture, that's step one, and then the second piece of data that we need is just the texture coordinates that we're going to put into our vertex buffer when it's time to actually draw one of these textured quads. So texture, and then vertex texture coordinates. That's it. Now, how we choose to calculate this and abstract this away is, again, one of those things that's going to be really dependent on the usage. So how are we planning on using this? As someone who's writing the code for this quote-unquote game that we're making here, how do we want to, I guess, deal with textures that are actually subtextures inside texture atlases? Well, ideally, we probably still want to deal with them as if they were separate textures. That's probably the best way to do things. So in other words, we probably, when we load a sprite sheet, we probably want to define all of the different textures and maybe make variables out of them inside our layer, inside our level class, wherever it may be. So we load a texture, we define all of the different subtextures, and then when it's time for us to render, because we still will be calling draw quad with an appropriate texture, this time maybe we can pass in that definition of a subtexture instead of the full texture. And that way we can still have just one actual texture loaded in memory on the GPU ready to be bound, and then the rest is just determining some kind of set of vertex texture coordinates. That's probably the way that we're going to go, but let's dive in and actually take a look practically at what that would look like. So this is what we had last time. We had all these particles and we had these stairs rendering just to test out everything and make sure that it is okay. But right now, let's think about this. We're drawing a quad. We pass in a texture. What we actually probably want to do is, instead of passing in M sprite sheet, we want to pass in maybe M texture stairs or something like this, specifically to draw the stairs. Now we know, if we go back to render a 2D, we know that the stairs themselves, let me find the appropriate function, that the stairs themselves here in our draw quad function that we worked on last time are at 7, 6. That's the coordinate of the texture inside our sprite sheet. And if we quickly open up our sprite sheet, then we can look at that. So these stairs over here we know are, and I don't know what Visual Studio's look at this, what Visual Studio's image editor is. Don't think I've ever used it before, and I'm not digging this kind of green background. But anyway, attempting to explain this is a little bit hard, and I can't select anything because it moves everything, but whatever. So these stairs, as we know, are the 7th sprite on the X. I'm not even sure I'm looking at the whole thing. There we go, I can zoom out with the controller and the scroll wheel. 7th on the X-axis and 6th on the Y-axis. So that's where it is. I want to be able to make a subregion out of that, and then all of this calculating that we see here is something that actually needs to be done automatically. I don't want to have to deal with this. I just want to be able to define everything up front, have it linked to an actual sprite sheet being the actual OpenGL texture that we want to bind and render with, and then everything else is going to be automatically calculated for us. I think another more generic way to go as well is to just make something that is essentially a subtexture. So instead of texture 2D, we could have subtexture 2D, and that represents just one part of an actual texture. This could be relatively easy to define because, again, a subtexture could literally just be a texture 2D ref like this, plus these texture coordinates, which we could calculate upon like constructing, because another thing is doing all of this maths every single time we draw a quad with this image is probably not a good way to go. I mean, it's not required at all. So generally we want to avoid doing work every frame and every cycle and every time we call this function if we can, and I think that we can. So I think I will actually go down that route just because I feel like it's generic enough that it's going to be totally fine. And it also kind of allows us to not tie ourselves directly to the concept of sprite sheets or texture atlases, because that's something that is obviously very specific to these types of games. And I probably don't necessarily want to stick to that terminology. So let's kind of start writing this thing. And again, this is something that I've literally just come up with on the spot. So if we end up doing a complete backflip, then so be it. So let's go into our texture class here. This is one of those things that, again, doesn't need to be render API specific whatsoever. So we have inside platform OpenGL and then OpenGL texture, we have specifics to OpenGL textures. However, this concept of a subtexture doesn't need to be specific whatsoever. Now, do I want to define the texture class in this file? I'm thinking probably not. The reason that I don't think I will is because this, as you can see, is specifically to do with like renderer objects. That's also why it's inside like the renderer folder. Not that that's like a huge indicator of what should be here, but my point is these are literally things that we create for the intention of creating them using a render API and having them as objects on our GPU. They're basically primitives that we use for rendering. So what I'll do is I'll create a new item, and I'll make sure I'm in show all files mode, because if I'm not, then it's just going to create it in the root directory with my project file, which is not what I want. And I will call this subtexture. And I guess I'll call it subtexture 2D because, well, that's what it is. And I do like descriptive names. So this is exciting. We're introducing a new class subtexture 2D. Now, this is not like a renderer primitive or anything like that, which is why like it's not going to follow the same pattern of having like a static create function or anything like that. This is something that you can just, create normally like a normal person. So we'll say const ref texture 2D. This is basically what it's wrapping. This is our actual texture, and this is also something that is going to end up storing. So we'll say ref texture 2D texture. However, we may actually end up providing some kind of static creation functions just to make this a little bit easier. So in other words, we could basically choose to create something like as a sprite sheet and then pass in like the size of each sprite, for example. But ultimately, as I mentioned before, our goal here is to have a set of texture coordinates. So I'll say text coords. We'll have 4 of them. We know that we need 4 of them. Let me just include GLM here as well, /GLM. I'll extend this constructor to be the most kind of general case. So in other words, this is basically going to be like the minimum bound, and then we're going to have a maximum bound as well. Let's also create a CPP file for this subtexture. So subtexture2d.cpp will include our PCH and also our subtexture2d. Once I've done that, I'm just going to go and implement this constructor. Now, this is going to obviously set our texture to be texture. And then with calculating the texture coordinates, this is really where the meat is going to come into play. Again, the core of this, and I'll write this out very simply, is going to be this. These are supposed to be texture coordinates that you pass in if you want a subtexture. It should be very simple in that sense. So texture coordinates 0 here are going to be min.x and min.y, if you picture this being like the bottom left corner. And I'm just writing them out like this so that they match up and it's easy to read. Then the texture coordinates for the bottom right side are going to be max.x and then min.y. Then we're going to have max x, max y, and then we're going to have min x and max y. So now we have every combination of these, and these are in fact our correct texture coordinates. Now this is fine, and this is really all we need. We could really provide like any mechanism we want to retrieve these texture coordinates. We could even make renderer2d a friend class. However, I think what I'll do, if we just go back to renderer2d, it's always good to check your usage, obviously. So what are we actually going to need? Well, we're going to need this kind of pointer of texture coordinates where we're going to want to copy from at the appropriate index. So just by having like an index should be pretty good, I think. So going back here, what I'll do is I'll just write a function that retrieves our texture coordinates, and we'll mark them as const here as well. Okay, so now we have the texture coordinates, and then I'll also, of course, need to get this texture as well. Okay, so this is really all the subtexture class needs to be. As you can see, it's really simple. That is at its core the data that we need to turn everything into essentially a sprite sheet and more importantly, be able to actually access those individual sprites. However, as I mentioned, it's going to be very useful to us to be able to create these things without having to actually specify the texture coordinates and having to compute them. So what I'll do here is I'll add some static functions, static ref subtexture 2D, create, and these are actually going to basically function as helper functions for us so that we can create them as if they were a sprite sheet. So I'll do create from coordinates. So create from coordinates or create from coords is basically going to be what we did in the renderer 2D class, which I'm just all over the place with my code. All right, so basically this, right? What we did here is we created them based on a set of X and Y coordinates that we specified here, and then the width and height of the sheet, as well as each individual sprite width and height. So if we go back here, all we really need here is the X and the Y coordinate, as well as the sprite width and the sprite height. So if we have these two pieces of information, and in fact, I think what I'll probably do is end up converting them into vec2s here, vec2 sprite size, and then I'll implement the function, of course. And then what this is going to do is attempt to create these min and max variables that we need here using this information. So let's go back to renderer 2D so that I don't have to copy too much code here. I'll just copy all of this, I think, and delete all the stuff that I don't need, such as this stuff. All right, so min and max, let's work them out. The coordinates X and Y just become the coordinates. Sheet width and sheet height is also just the texture's width and height. Actually, one thing I forgot that's kind of important is to pass in this texture. Now, do I want to do it at the start or at the end? I think I'll do it at the start just because it is like the most important thing. Let's add this here. Okay, so remember, we really only need 2 of these because everything else we'll just calculate using this. So this here is the bottom left corner, and then we have the top right corner. These are the only ones we need. So I'm just going to delete the other 2 here. And then let's start with changing this. So first of all, X times sprite width. X is of course going to be from our coordinates. So we'll do coordinates.x times sprite width, which is going to be our sprite size, I think, sprite size.x. And then coming over here, we have coords.y times sprite size.y. Sheet height is going to be texture get height. And sheet width, of course, is going to be texture.get width. We can get rid of these. We obviously don't need them. And then we have the same thing over here again, coords.x plus 1, sprite width, sheet width, and then sprite height, which is sprite size.y. Y, of course, is coords.y, and then sheet height is just texture get height. All right, cool. So that's basically all we need. Now, instead of having this const expression, which obviously isn't even a const expression, we'll get rid of it. And then really all we need to do here is create this. So ref subtexture 2D, we'll say result equals create ref. Let me get rid of that space here. Create ref subtexture 2D, and then we just need to pass in the texture as well as the min and max. So just to make this a little bit better and a little bit easier to read, I will actually bring it out here and I'll say min and max instead of putting it into the constructor, which I could have done as well, but it's okay. I think I'll just leave it like this so that it looks better and makes more sense. All right, let's take this, and this will be our max coordinate here. I think everything's correct. Yeah, it should be. And then we'll just pass in min and max here. All right. So again, this is, and we can just return this. So this is just supposed to be, I think I've got a comma there. All right, so this is what we look like. This is just supposed to be a little convenience function to basically calculate these things for us so that we can give it some simple data and just create them from coordinates instead of having to calculate the actual texture coordinates on our own inside the sandbox class or inside our game, because we don't really want to be doing that. All right, so now we just need to go into our renderer and actually change the function to work with this. Now, technically, you probably want to implement this for literally every single function that takes in texture at least. So what I'll do is I'll do draw quad here. I probably won't do it. Well, I guess I should do it for everything for completeness. But what we'll do is we'll change this to be a subtexture 2D, and we'll leave, I think, we still want a tiling factor and a tint color, obviously, as before. I'll include subtexture 2D over here. And let's also copy and paste rotated quad, and we'll update this to take in the subtexture as well. So we have quite a few new functions here. Let's go ahead and implement all of them. I'll grab this. In fact, I think what I might do is, instead of implementing them that way, first of all, I think what I want to do is revert our function that we actually modified, which was this one, to be what it's supposed to be. So if we go to like literally any other function and just get the texture coordinates, that's really the only thing we changed. Let's paste them back here, and I think we can obviously get rid of this. I think that's exactly what it was, so that was easy. And now what I'll do is every function that had that, I'm just going to copy and paste it. Now at this point, a lot of it is the same. Really all we're doing is calculating texture coordinates. So you could actually bring this out and make all of this into one function and then call it with like the texture coordinates and stuff like that. We might do that in the future. I'm not gonna rush in and do that right now, because it's not really necessary. It is unfortunate that we have so much duplicated code though, which is why we should probably do it, as I mentioned before, but this is just the way it is for now. So all of this stuff, it still stays the same. Really the only thing that changes is the texture coordinates. This, us trying to like find an appropriate texture and like put it into the texture slots, all of that stuff, that still stays the same. It's just that what happens is when we actually get the texture here, this is a subtexture, and I'm gonna label it as such so that we don't confuse it, because we still need the actual real texture to render, because subtexture is kind of just a wrapper over it. And in fact, I'm just gonna call this subtexture as well so that we don't get confused. So going back here, this is just going to call draw quad with subtexture, which we'll call this overload. And then what this is going to do is, again, these texture coordinates, instead of being taken in from somewhere else, we're going to take them in by calling subtexture. What was this? Subtexture.get text coords, like this. And then this will just be, I think, a const pointer like this, and we can access them in exactly the same way. So this code does not change whatsoever. But then texture, which we don't have now, we also need to retrieve. And we can just do that by writing const ref texture2d texture equals subtexture get texture. And that's it. And you can see everything else will work fine. So that's this done. And then now we need to do the same thing for our rotated quads that take in textures, which are these. So let's copy and paste this. And yes, I am now definitely regretting my decision to not kind of put this into one function. We might have a little maintenance episode where we both move this out into like another class, like specifically this like game that we're kind of working on here. And then also we'll take that opportunity to like, you know, clean up the renderer class and do all of that stuff. So let me grab both of these lines of code. Where are they? So this, and this. If we go down here, this becomes that. This is a subtexture now, and I think everything else should work fine. Now, obviously, you know, we need to test this because I just implemented this off the top of my head and it might be wrong. But the idea is, let's test this out. So the idea is we have a sprite sheet. We still load that in normally as we always do. But now the difference is, and if I go to the main Hazel header file, we will add in subtexture over here so that we can actually use it. So subtexture 2D. So we do subtexture 2D just like this, and then this will be like our stairs, you know, let's just do texture stairs. And then the way that we're going to kind of, I guess, initialize this and use it is on attach. When we create our sprite sheet, we'll just do texture stairs equals Hazel subtexture 2D create from coords. And then this will be our sprite sheet. And then the coordinates here are going to be 7, 6. Now note that you can like create half textures and stuff like that if you wanted to, because these are floats. So that's totally permissible because the maths like makes sense here, even though logically it might not. Sprite size is 128, 128. Okay, so that just creates, that should work, right? Because that's the size of these sprites. And I think that it should just work. So let's hit F5 and see what happens. Hopefully I haven't made any mistakes. Okay, so we're already not compiling. Let's take a look at this. We have, oh, these are linking errors. Okay, but yeah, that's because this didn't compile. Texture coords and definition, we forgot to delete the other one. Let's run this again. And there you go. Looks like we see the stairs again. I really have no way of knowing if that worked or not because it looks exactly the same. But let's open this again inside this wonderful image editor that we have inside Visual Studio, and I unfortunately keep trying to zoom out with Control minus, but that just closes everything, it seems. Okay, shall we go back to, well, you know what, we don't even need this, right? Okay, so first of all, what's going to happen if we go out of bounds? If I specify an index off of this, then, you know, texture coordinates still work outside of bounds. It's going to either repeat or it's going to clamp. It's going to do something. So that shouldn't really crash. Let's do, what was this bush? I don't really remember. Okay, well, let's try a new sprite. How about that? Let's try this kind of barrel thing. So it's clearly the third sprite from the bottom, which means it's index 2. And then here it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 2. Let's try that. So we should get a barrel if we change. And in fact, what I'll do is I'll render both. That'll be a good test. So we'll do texture stairs and texture barrel. So 8, 2, right? Let's copy this and paste this here. 8, 2, I think is what my barrel was. Okay, so we're creating it from the sprite sheet, texture barrel, and then I guess I'll just render it. Let's render texture barrel, and we'll render this maybe at an offset of like 1. Yeah, 1 should be fine because I don't think they take up the whole space, or at least the barrel looks like it's a bit thin, so we should be fine. All right, there we go. We have a barrel, we have the stairs, we're clearly rendering correctly from our sprite sheet, everything looks good. So that is our new SubTexture class. And in fact, one final test that I think would be useful is if we open the texture again, let's try and render one of these trees, like this orange tree, for example, because this is actually, it's not a square sprite. So which one is it? So 0, 1, I guess we'll have to give it the index 1 on the y-axis, and 0, 1, 2. So it's 1, or it's 2 by 1, and then it has to be twice the height. So to do that, let's go back here. Let's do texture tree. And then over here, we will assign it to, let's grab that. Sprite sheet. So what do we say? 2, 1. Is that right? I always forget these numbers. 0, 1, 2. And yep, okay, 2, 1, I was right. And then 128 by 256 tall. So I guess in this scenario, this would refer to not necessarily the size of each sprite, but the size of this particular sprite. And obviously that means that it's going to take up twice the height. Now, this is actually, now that I think about it, it's probably it might work for this scenario. In fact, it probably won't work for anything. And the reason is that obviously we multiply these coordinates. So this kind of +1 thing, this is really what we want to change to 2, right? Because if we change the sprite size and we multiply with that, then obviously it's still going to, it's just going to be a different kind of coordinate. We're going to be dealing with a different offset, and it's still going to be the same because we're specifying our min and max bounds. So that's something that we should probably fix. And the only way that we can really fix that is probably by providing a third parameter. Well, we have sprite size. In fact, you know what? Let's set that to be 1 by 1 by default. And then we'll say const glm. And this is going to kind of make it even more confusing. But we'll maybe say cell size. And cell size is going to be kind of each grid cell, how big it's actually going to be. And then we've got sprite size as a default parameter. So let's go and copy this. We'll go back and we'll have to make sure that everything's working. But basically, cell size now is going to be what X and Y is. So I'm replacing all of the sprite sizes with cell size. And sprite size, on the other hand, is what we're going to actually increment here. So the chords get incremented by the sprite size X and the sprite size Y. And really this only happens for the max parameter here. Okay, so let's go back. Let's change this. So the cell size is still 128 by 128, but what we do here is we set a size of 1 by 2 instead of the default of 1 by 1. So now I guess I'll just add in the tree here. So we'll have our tree texture, and let's draw this on the other side. So we'll do -1, and then that's not my tree texture. And then maybe this will work. Oh, last thing we need to do actually, let me just cancel that build quickly because I don't want to see the wrong tree. Let's make the height of it 2, right? So it's twice as tall, obviously. Otherwise it's still going to render it on a square quad and it'll be very squished. Okay, so what do we have here? Okay, brilliant. There we go. It works. So now we see this. Now, importantly, like we would have seen this before as well. We could have set it up by just drawing 2 sprites on top of each other. But obviously by doing it this way, it's a single quad and we're rendering the entire texture on it, or specifically the entire tree texture on it. We don't need to split it up into 2 quads because that can be a little bit annoying to do. right? Especially if it's just like a little tree texture. We could even make it just so that the first quad maybe functions as a collider or something like that, so you can go behind the tree like that if you're the player. There's a lot of things you could do here, but it's cool, of course, that we're rendering it as one quad here. So there you go. Okay, so I hope you guys enjoyed this video. If you did, please hit that like button. You can also help support the series by going to patreon.com/the Cherno. You'll get access to plenty of really cool perks, such as access to the 3D development branch of Hazel, as well as live streams. For this month of May, I've actually halved the price to get in on the live streams that I'm doing every single week of me developing Hazel. So if you guys are interested in seeing me actually work on Hazel Dev, the 3D version of Hazel, and all that stuff, then definitely check that out. And thank you so much for your support. We've got this SubTexture 2D class now, which is pretty exciting. We can actually start putting together some kind of map and rendering it, whether that be just by like having a file that maybe maps out where each tile goes. We also might do it from like a string. We could even like use a noise algorithm to generate some noise and then assign different types of tiles to that. I don't know. We'll figure it out. If you guys have suggestions, leave them in the comments below for what you want to see. But this is good. I'm happy with what we've got here. We're slowly working towards extending the Hazel API through actually making a game. And I think that's probably one of the best ways to make a game engine. It's to, like, once you've done the core stuff, and we kind of have done a lot of the core stuff in Hazel thus far, once you've done all of that stuff, you can just, like, you know, sit down and actually start trying to make a game with it and then filling in the blanks. And that's what we're doing. I think it's working really well. Can't wait to see you guys in the next episode, honestly. We can keep working on this game. I will see you next time. Goodbye.